Yes, good morning. And first, look, congratulations to the conference organisers, excellent conference, and just in recognition of my co-authors as well. The conference yesterday talked about obviously our resilient pasture systems are underpinned by the soils resource, and that includes sufficient organic matter as a source of nutrients for plant growth, importantly as a food source for obviously our biological community, but also an aggregate building which underpins soil structure and obviously water storage. And it's really organic matter and the physical properties of the soil drive most of those provisioning and regulating service we enjoy from our soils resource. The fertilising sheep grazing study at Ballantrae that dates back to '75 provides a unique resource to look at the long-term implications of our grazing practices or our pastoral systems on that soils resource. And I need to recognise people like Greg Lambert and Dave Clark who, in their vision in actually setting up this. It's a site in Southern Ruahines, just above the Manawatu Gorge. And I want to talk about some of the findings that have emerged from those long-term sites, and there are 3 farmlets I want to discuss. One that's had no fertiliser since 1980. It's dominated by low fertility grasses and legumes, things like suckling. Produces around 7 tonnes, low utilisation, struggling to carry 7 stock units. A system that's had a low input every year since 1980. Still dominated low fertility grasses, but some white clover. Growing just under 10 tonnes, stocking rate of around 10. And the high fertility system, which is receiving 375 since 1980. 50% ryegrass, white clover, growing just over 11 tonnes when the last measurements were made in 2015, 2016, nominally carrying 15 stock units. Now we know a lot about, we've tracked the nutrient fertility of these systems back since '75. In 2020 when we sampled that no-fert system, struggling Olsen P's below 5, the low system's around 12, and the high systems peaked out at 50 back in the early 2000s. In theory it should be continue to go upwards, which is an interesting story in its own right. Those analyses are averaged over slopes and aspects. Now nutrient fertility is just one component of soil health. There's 3 other components. I want to focus on the bottom one, which is soil organic matter in there today. If we look at in 2020 from a sampling of the topsoil, 0 to 7.5, and looked at soil organic matter concentrations, averaged across slopes and aspects for all of those farmlets, that farmlets have had no fertiliser since 1980, concentration 5.1%, system has had low input 5.1, and the high fertility system 5.4. So suggesting a little bit more carbon in the topsoil as a concentration. If we multiply concentration by bulk density, one other slide first, So compared to a little effect of history on concentrations, we certainly find that the concentration of carbon is essentially lower on those high slope components of the landscape compared to low slope. So close to 6% on low slope, high slopes above 25, that carbon concentration is down to 4.25. And we get an aspect effect, and particularly northwest tends to be lower than the other 2 aspects. Should point out though, all those soil organic matter concentrations are in that optimal range, a range that was defined by Sparling back in 2008. They're all between that 3 and 5%, 3.5 to 7% for brown soil. If we take those concentrations and multiply those by bulk density, we can start talking about how much the soil carbon stocks in tonnes per hectare. If we go along the bottom, the grey bars, the no-fert 31.6 tonnes and that 0 to 7.5 across to 34 tonnes under high fertility, suggesting again a little bit more carbon in that high fertility system. But if we go to the next depth, 7.5 to 150, another 30 tonnes, and then up to 30 centimetres, another 50 tonnes, total carbon to depth across those farmlets is all around that 110 tonnes, suggesting that history is having very little effect on those stocks. Again, all around that 110, despite the large difference in production across those systems. We're also struggling to actually find over time, if we compare 2003 with 2020, across the farmlets on average 110 tonnes. I'll come back to that a bit later. One of the beautiful things that's coming out of this long-term study is that we're building our knowledge of the dynamics of carbon in these hill country environments. We're starting to get a better feel for what are the temporal and spatial variations in carbon across these landscapes. And one of the benefits of that have emerged from work with the Hill Country Futures program is that we're finding that that medium slope provides a really good representative site for characterising soil organic carbon concentrations across all those slopes and aspects. So it gives you an interesting window. So in conclusion, I think the insights from the long-term site is that concentration stocks are stable under permanent pasture under a wide range of fertiliser and sheep grazing strategies. The concentrations in the topsoil are in that optimal range for sustaining soil health, and we should celebrate that. We're sustaining these systems, and we should be measuring and reporting on that. And lastly, soil samples collected for soil fertility monitoring are suitable for monitoring soil organic carbon concentrations, not necessarily stocks. Thank you.